Okay, welcome back, everybody. We have a video today about rectangles. So we're going to learn two very important theorems about rectangles, and so it should be a relatively short video. There's no examples on this video today. We'll look at our assignment to get practice with that. So first of all, what is a rectangle? Well, you probably know, but there is a mathematical definition of a rectangle. A rectangle is a quadrilateral with four right angles. So you see the quadrilateral with four right angles, A, B, C, and D, and so that is a rectangle. Okay, the first of our two important theorems is that a rectangle is a parallelogram. That's actually more important than it sounds like, because once you show that a rectangle is a parallelogram, any theorem that regards parallelograms then applies also to a rectangle. So we're trying to prove that a rectangle is a parallelogram. So in this drawing here, you see a rectangle given A, B, C, D. And we're trying to prove that side AB is parallel to side CD, so the left and right sides. And we're going to also try to prove that the top and bottom, BC and AD, are parallel to each other. Once you've proven that, then you have proved that the rectangle is a parallelogram by definition. Okay, so here's the theorem we're going to use. This is an old one, so let's read that. If two lines are cut by a transversal and same side interior angles are supplementary, then the lines are parallel. So if you think of, here's your two lines, top and bottom, and they're cut by this transversal, which is the left side. So if two lines are cut by transversal and same side interior angles are supplementary, then the lines are parallel. So you can see angles A and B are the same side interior angles, and they are supplementary since they add up to 180. They're both 90. That makes the top and bottom parallel. So I'm going to go ahead and mark that off here. Top and bottom are parallel. Okay. Now let's use that same theorem, but with different parts of the drawing. Let's say this time here's two lines, the left and right sides. This time let's consider the transversal to be side AD. So there's two lines cut by a transversal, and that makes angles A and D same side interior. And notice that angles A and D are both 90, so the same side interior angles are supplementary. So that means the lines A, B, and CD are parallel. So I'm going to mark that off. Okay, so we started with a rectangle. We showed that the top and bottom's sides are parallel and the left and right sides are parallel, so that makes it a parallelogram. So now it has all the properties of a parallelogram. Okay, so our last theorem, there's only two today, last theorem is we're going to prove that the diagonals of a rectangle are congruent. So we're going to prove in this diagram that you see that diagonal AC is congruent to diagonal BD. Okay, so we're going to do it by proving two triangles congruent. So I'm going to highlight the triangles that we're going to prove congruent. We're going to prove triangle BAD congruent to, let's make this other one a different color here, triangle CAD. All right. So we just proved that a rectangle is a parallelogram, and remember that opposite sides of a parallelogram are congruent, so we can say that BA and CD are congruent because opposite sides of a parallelogram are congruent. That's a parallelogram. We also see that side AD is a common side of the two colored triangles. You could separate them mentally, but there's an overlapping common side there for those two colored triangles. And also notice that the yellow triangle and the blue triangle have a right angle. And so those two triangles are congruent by SAS. So the yellow triangle and the blue triangle are congruent by, let's get the pointer out here, side, right angle, side for the yellow. And the blue, side, right angle, side, so SAS. Okay, now, notice now the two diagonals of the rectangle are the hypotenuses of those two colored triangles. So now we can say what we're trying to prove. We can say that segment AC is congruent to segment BD by CPCTC. Corresponding parts of congruent triangles are congruent. All right, those two diagonals of the rectangle are also hypotenuses of the two triangles, the two colored triangles, which we proved to be congruent. And so those two hypotenuses must be congruent, which are the diagonals of that rectangle. Okay, so that's what you need to know. All of our problems today deal with these theorems. So let me recap them quickly, and then, like I said, there's no examples in this today. We'll look at the assignment and work some of those together as examples. But the two theorems you need to take away from today's lesson is that a rectangle is a parallelogram. We've proved that a rectangle is a parallelogram, and so it has all the properties of a parallelogram. And then the other theorem we just proved today was that the diagonals of a rectangle are congruent. The diagonals of a rectangle are congruent. So if we know those two theorems about rectangles, we should be good to go for this assignment. So let's get some practice. Thanks. Bye.